Hello everyone, welcome once again. Now we are in the last phase of the DMAC cycle. Define, measure, analyze, improve. We have already completed. Now we are sitting in the control phase. And we have come a long way since we started. We started our discussion from collecting the voice of customer, and now we are here sitting after implementing the solutions. We are here to monitor those solutions. So we'll do a small recap of what we have done so far in all the phases, and then we'll talk about the control phase. What are we going to do in the control phase? So we started about understanding two kinds of methodologies, which are very primary methodologies of the process improvement. It starts with the lean as a methodology, wherein we talk about reducing the waste from a process, waste which can create a bottleneck in the process, which can delay the process, which can create defects in the process. That's called the waste. And the another methodology that we talk about is called Six Sigma, which helps to reduce the variation in a process. Lean as a methodology was practiced heavily in Toyota as an organization, and Toyota has been the birthplace of many lean related methodologies. We have talked about a lot of them in our session. And then Six Sigma as a methodology was invented by an engineer called as Bill Smith in Motorola in 1981. And since then, Six Sigma has been in the forefront of process excellence among various industries in the world. Six Sigma was made popular by Jack Welch, the CEO of General Electric, or GE as an organization. He trained his entire manpower in Six Sigma because he believed heavily in the success of Lean Six Sigma. And then that's how Six Sigma has been in the forefront. Six Sigma follows two methodologies for improving the process. One is used for the existing product and the process. We call it DMAC, define, measure, analyze, improve and control. This is the methodology that we have understood so far. While the other methodology is called DFSS, designed for Six Sigma, in which we follow a framework called as DMADV, define, measure, analyze, design and verify. Two methodologies we have. So while DMADV is used for designing a new product, process or service. Here our focus of training is on DMAC, define, measure, analyze, improve and control. So as part of the define phase, the first phase, we talked about understanding the customer requirement, which is called a VOC. Now VOC can come from various sources: question, email, survey, feedback, service calls, warranty calls, KPIs, dashboards, or verbal or focus group discussion. These are some of the sources of voice of customer. And then we convert the voice of customer into measurable requirements called as CTQ, or critical to quality. And that critical to quality has to be measured in terms of numbers. Basically, we are quantifying the VOC. And then we try to prioritize the customer's requirement using a method called as CANO model. CANO has two contexts. One is we have to segment our customers, and accordingly we have to prepare or prioritize our processes, service, delivery or the products. For example, a basic model of a car will have less features, intermediate model of a car will have more features, and the top model of the car will have more features. So depending on that, the costing will be required accordingly, and that's how the car will be designed. What customer want, what kind of customers we have. That's CANO will help in terms of must have for those type of customer, good to have for a separate type of customer, and delighters for the separate set of customers. And another context of CANO is what can we deliver to the customer at a given point of time. Maybe as part of project we cannot fulfill all requirements in the current scenario or in the current time, so we may take 3 months to set up the must-have requirements, then another 3 months for good to have, another 3 months for delighters set of requirements. So that's about the CANO model. And then we talk about the putting these things into a document called as project charter, in which we project charter, which is a synopsis or summary of the entire project, wherein it has key elements. It helps us to understand the project requirements, the project team and the communication goals and the scope part. The 6 key elements of project charter are problem statement, business case, goal, in scope, out scope, project team and the milestone. The problem statement talks about the pain or problem which is set by the customer. It talks about how much pain is there in the process. We try to quantify the customer's issue, the context we try to understand, and we try not to put any root cause or any solution. If you know already, then we can solve the problem just like that. We don't need the entire DMAX cycle and just like making a charter and do all of it. Maybe we can just solve the problem the way if we know any solution, if we know the root cause. And we do not try to blame or complain or crib about anything while we are preparing a problem statement. In business case, we ask questions: why do we need to solve this problem? Why do we need to solve the problem now? Why should the organization give us resources, money and time to solve a problem? Because that urgency and need has to be presented in the business case statement as part of the charter. And then we talk about goal: how much should we improve, by how much, and by when we should improve. Then we talk about in scope, out scope. What is in the scope of solving this problem? The boundary of the process, which we would take as a project. Anything beyond the boundary of the project will be called the out of scope for that project. So that's in scope and out scope has to be determined very well. And then we put together a team. Typically has 4 set of people: a sponsor, a project coach as a project leader, you, and then an SME who will be helping you to understand the entire process. And then we prepare a project timeline as to what activities we shall complete as part of this project, what are the different timelines and the milestones. Charter is ready, and now as we had a project team, we shall like to assign the roles and responsibility of each team member in the team using a method called as RACI diagram or RACI model. RACI stands for responsibility, accountability, consultation and inform. These 4 parameters we have. And the key rules about RACI is that at least one accountable should be there for one activity, and there should not be more than 2 accountable for any activity. Typically, exception cases you can have, but typically we do not have more than 2 accountable for an activity. And then we also prepare a communication plan to ensure that everyone in the project should be kept updated about what we are doing, how we are doing, what meetings are happening, what have we accomplished so far, what are the challenges, what are some updates. So that communication plan has to be prepared, and everyone needs to be part of it. All the key stakeholders need to be kept updated. And then we do a stakeholder analysis. That becomes important when we have multiple stakeholders, and we have to ensure that all the stakeholders are kept engaged in a project that can be politically sensitive. For example, a project which might face resistance from a lot of people. So we need to identify who those people are, because they can prove very important when it comes to deployment of solutions. So these kind of stakeholders needs to be identified now, kept them engaged, updated and informed during the entire course of the project. And that's when stakeholder analysis gets completed. And then we talk about mapping a process at a high level. Mapping a process at a high level, we talk about there are different elements of a process, starting from supplier, input, process, output and customer. These are the 5 level of elements in a typical process that we look at, and we map a process on those 5 elements. What are the key inputs, what are the key outputs, what are the key process steps. This helps us to understand the key boundary of the process, the start and the end point. Also help us to understand the dependency of our metric that we are improving, if it has a dependence on any other metric. That's when define phase gets over, and we have a toll gate review at the end of the define phase. As part of the define phase, there are 2 set of review that happens. One is done by the business sponsor, one is done by the project coach. They are sitting in the same review. Business sponsor will be asking questions on the business side, that are we solving the right problem, do we have any challenges, do you have a charter, do you need any support, while the project coach will be asking questions based on the Six Sigma methodology as to are you following the Six Sigma methodology, do you know how to use certain tools, are you using them right, do you need any mentoring or support in any of those tools. That's why the project coach comes into the play, and these questions are asked as part of the define phase. The key deliverable of define phase are the project charter, SIPOC, communication plan, and RACI model. That's where define phase gets over, and we move to the major phase. As part of major phase, we collect data. Data which of 2 types: discrete and continuous type of data. Discrete data, which is count data, categorical data, while the continuous data is which can be divided into multiple parts. It still has a meaning, it has a measuring unit, a measuring scale. So we do a data collection. Data collection means we are collecting a sample has to be random and stratified, and we put that into a data collection plan where we need to have an operational definition. Data should be stable, collected over a period of time, should be measurable. And then we do some basic statistics on the data, where we try to understand 2 things from a process point of view. What is the central tendency of this process? That we understand through mean and median. And what is the variation in the process? That we understand through range and standard deviation. We use mean as a process performance or a central tendency parameter when the variation is not much in the process is spread evenly. But if there is a lot of variation in the process, we look at median as a process performance parameter for the central tendency. Range we look at for small set of data as the variation measurement for the process. But when data is large, then we look at standard deviation as indicator for process variation in measurement. So this central tendency and variation, we try to visualize them using some graphs also. We looked at histogram, we looked at box plots, we looked at Pareto chart, we looked at scatter plots, and then we talked about how do we understand. Now we know there is the center of the process may be away from the target, this variation in the process may be too much, we are visualizing also, but are we meeting customer requirement or not? That to understand through capability study of the process, that are we within the lower specification limit and upper specification limit of the customer. That's what we try to understand here. And for that we use a methodology wherein we try to calculate the DPMO, which is defects per million opportunity, where we get some understanding about what are defects, what is a unit, how many opportunities for defects are in one unit, how many total opportunities are present, how many total defects are there. Then we calculate DPU, called defects per unit, and then we calculate defects per million opportunity. Basis the DPMO value that we receive, we then try to calculate the Six Sigma or the sigma level of the process that we can use. For that we can use a lot of online calculators available, or we can use a table that will have the sigma value versus the DPMO in front of it. And then we also talk about the key concepts of the process mapping. So what we saw in defined phase was high level process mapping, and now here we are looking at the detailed level of process mapping. For example, we look at activity chart, we look at the swim lane chart, we look at the value stream map. Swim lane, we have multiple functions business, how do they interact in different lanes, that's understanding we receive. We understand the total lead time, what is the time of each lane, where are the multiple bottlenecks, and so on. While the value stream map tells us the steps that we are doing, are these really making sense to the customer, are they adding value to the customer. So we do a value added, non-value added analysis. We then also look at different type of waste that we encounter in a process, where we can have 7 types of waste. Acronym is TIMWOOD, TIMWOOD: transport, inventory, motion, waiting, overproduction, overprocessing, and the defect or the rework. And at the end we have the major phase. Again, the way we had the defined phase toll gate review, where we have business sponsor sitting in and project coach sitting in, asking you the same question: should you go to the analyze phase or not? If you clear it, you move to the analyze phase. So that's the session 1 on the recap of the define and measure phase. In the session 2, we look at the recap of improve and analyze phase before we talk about the control phase. So thank you for watching. This is Shivendra Sharma.